Linda laid out very well the high-level view of the National Petroleum Council study. And what I want to do is now have you follow with me down one of those half a dozen pathways to see how, for example, the electrical panel is working. And secondly, within that sub-team, how specific questions are addressed. And because there's enough time to do this study right, meaning we don't have to, we do a lot of work, but it's time to reflect on what we're doing as opposed to meeting a deadline. And so we all appreciate the way that Linda runs this operation. JC, you may know, is the co-chair of the electrical sub-team with Bill Reinert. And today I want to just give you an idea of what they're up to from the level of the sub-team. Okay. These are the members of the electric subgroup. And if you notice, there's a fairly decent breakdown. We have utilities here, we have car companies, we have manufacturers of electrical components, and then in the outer ring you see the energy companies, the environmental aspects, the academics, and so forth. So we have a really rich mixture of experts in these teams. And the question that came up earlier had to do with what do you do when Ford and Qualcomm are at loggerheads about how to do IT work in a car, for example. And it's remarkable, at least in this group, I haven't been privy to what the other groups are doing, but in this sub-team or subgroup, we have a really remarkable way of handling these questions in a harmonious fashion. And there'll be spirited discussions, the email traffic is heavy, but at the end, there's a pretty good consensus on how to proceed. And the insight there, I think, is if you get people who are used to making decisions, not with 100% certainty, but with some uncertainty, and moving on, that this actually can, this process that we may have had questions about at the beginning can actually work. So these are the members. Next, please. Now this slide is a little bit busy, but this is the outcome of one of the early meetings that we held with the entire group. And if you could read from left to right, you see we basically have two classifications of what we're concerned about as far as rolling out the electric vehicles in the broadest possible way. The vehicle itself is obvious. And then we have infrastructure, and infrastructure is a major concern when we're talking about getting a distributed electric grid which may or may not have the capacity that's needed, and how we bring that about. Now, of all the concerns in the vehicle area, of course, batteries jumped out immediately. And we're focused primarily on the lithium battery that we all know about, but there may be some technical improvements over time, and we have such a long time span looking from 2010 to 2050 that we have to rely on our experts to a significant amount to get the best guess at what's going to happen. And we try to attach some uncertainties to these numbers so that that confidence interval percolates through the entire calculation. And we'll be doing that more with the second report. The first report was issued yesterday. Infrastructure. To use electricity on a broad scale, which is our mandated, the first phase of this work, we need a significant amount of infrastructure. And when I give the second part of my presentation today, we're going to see that infrastructure is fairly pricey for certain aspects. And we have someone ask about communications, and you see about 2/3 of the way down the slide. On the right, the ITS aspects of both electric vehicle operation, charging, and so forth. The acronym that you see frequently throughout this presentation of EVSE is so-called Electric Vehicle Supply Equipment. And that's the J plug that you saw a picture of yesterday. It's the box that hangs on the wall and everything that goes with it from the electrical panel to the car. So we group that in the EVSE nomenclature. Now, another concern that might come up would be standards. And we have in this country, for example, the National Electrical Code. It does not address EVSEs per se. It doesn't prohibit them, but it does not address them either. But there's a cycle of revisions to the National Electrical Code, and we simply will roll in that EVSE question. And that kind of thing is what the experts in codes that are on our group advise us and say this could be a hurdle or a so-called pinch point. We have to address it, but it's not a deal killer. Okay, next. Now, since we're looking at 2010 through 2050, there's also a time trajectory on a number of these topics. And so what we've come up with is the color code you see in the upper left-hand corner. And some of those may change over time. So we've actually allocated each of those items on the right to be rolled out over the next 40 years. What are the problems and what aren't the problems? And we'd like to see more greens than red, but there are some reds. For example, if you look in the upper part of this diagram, you see something having to do with safety considerations with the batteries. And we have all heard about this lithium fire that happened in a UPS cargo plane last fall with tragic consequences. And that is a major concern. Can I actually ship these batteries by air or even by rail because of that issue? So we have to think about those realistic aspects as well as some of the theoretical details. But these, I'm just giving you examples. There are many, many hundreds of hours of discussion that go on, and these are just a couple of examples. Next. Nomenclature. You know that electric vehicles have a number of different realizations in practice. The parallel PHEV is one which you see on the left, and basically the engine or the so-called electric motor, shown in yellow, can both power the drivetrain. An example of that is obviously the Prius. A series PHEV is one in which the engine never powers the drivetrain directly. So in this case, you see an engine either running a generator, and the battery that is charged by that generator runs the electric motor. And that's similar to what a Volt would do. And then the third realization, you see a fairly large battery there. That is the so-called battery electric vehicle, BEV. So we look at all these realizations and some others of the concept of electric vehicles. The battery icon that you see on these diagrams is relatively significant. For example, on a battery electric vehicle, you might have a range of 75 to 100 miles, all electric. The parallel PHEV might have 10 miles. So it's an issue of how large the batteries are traded off against the fossil fuel use for supplemental travel. So that's our nomenclature, okay? Batteries. Batteries are a big issue as far as what the battery is going to be and what will the battery cost. So what we have done in the concept that Linda outlined is basically, remember, we're not doing original research, we're doing a study of studies. And each of these items you see in the right-hand upper corner are 5 different reports from various battery experts and national labs. And you see that there's a significant difference starting now, but as we move out in time toward our 2050 goal, we see that there's some convergence of what people think the price of batteries will be. And we have this kind of a curve for many other features of electric vehicles, and we roll those into our calculation, okay? This is the diagram for infrastructure. That was, remember, the lower half of the original diagram that I showed. And basically, this lists more clearly what we're concerned about. The regulatory details are a concern at some point, so we need to pull that along with the technical work that we do in realizing these technologies. EVSE cost, I'll talk about that next time. in the next talk, and so forth. So you can read this for yourself, but it's basically, from the left, you look at charging at the residential level, at the commercial level, and then we have 3 different classifications of the power level within those. And we'll talk about that later as well, okay? This is a summary which I don't expect you to read, but we're trying to look at some special cases. So we have at the top, Linda referred to the annual energy report, the AEO. What is the acronym? Annual? Outlook, that's it. Right. And so that's our base case. And you look at the fuel mixture, which is used for electricity generation in this country, and you can see that in the copy that you have in your notes. And then we go into a renewable maximum case out by 2050 of 55%. And likewise with the other 2 energy sources that you see there, nuclear and natural gas. And the experts roll out through the next 40 years what they think that penetration is going to be. And you can look at these numbers yourself, but then we run, the question might be, what do we do with all these numbers? And what we do is we use a model called Vision. And Vision is our tool for allocating what the carbon burden of these various energy mixes will be. Can we achieve, excuse me, that 50% reduction that Linda talked about, or not? Or if we can, how do we do it? And that's where we're standing right now in this study. So again, you can read this for yourself. I want to point out the last 2 bullets here. The materials are a concern. And you've all heard about the question of where are the rare earths coming from. They're used in efficient electric motors as well as cell phones and so forth. So it's a concern that there may be a worldwide monopoly on rare earths, but we've looked at that with Linda's help again and found out that there may be a short-term concern, but in the long term, it's not going to be that much of a problem. Okay, we're at a stage right now where we've finished the so-called, well, we think it's the 85% first report level. Theoretically, it's supposed to be finished yesterday, but it's a work in progress. It does take a lot of time, but if the members of the committee are like me, we really enjoy the work and look forward to finishing up.